No, gravity cannot be used as an infinite energy source. In fact, strictly speaking, gravity itself cannot be used as an energy source at all. You might be confusing forces with energy, which are very different things. Energy is a property of objects, such as balls, atoms, light beams, or batteries. In contrast, forces describe the interaction between objects. Forces are the way that energy is transferred from one object to another when they interact. But forces are not the energy itself. Gravity is a force, so it just provides one way for objects to exchange and transform energy to different states. If I lift a bowling ball to the top of a hill and let it go, the ball falls, speeds up, and seems to gain energy. Isn't this a case of gravity giving energy to the bowling ball? No. Again, gravity is just a force, so it just describes how objects interact. The energy that the ball displays as a falling motion came from my muscles when I hefted the bowling ball to the top of the hill, and not from gravity. Gravity just provides a way to temporarily store energy in an object. We call the energy that an object gains when you lift it against a force potential energy. The energy comes from the lifting agent and not from the force. The force just provides a way to transfer energy from one object, my muscles, to another object, potential energy in the lifted ball. When I let go of the ball, gravity converts the potential energy of the ball to the kinetic energy, motional energy, of the ball. But the ball can never gain more kinetic energy than the total potential energy that I put into it by lifting it. This concept is true of all forces, and not just gravity. Two magnets attract each other and fly together, speeding up and seeming to gain energy. You may think that the energy has come from the magnetic force. In truth, the energy comes from your hand pulling the two magnets apart against the magnetic force. The magnetic force just provides a way for potential energy to be stored in the magnet, by virtue of you pulling them apart, not just by virtue of them being magnets, and then converted from potential energy to kinetic energy. Anytime you push an object to a new location against a force, you are giving it potential energy. It is true that gravity is unlimited in the sense that it never turns off. Earth's gravity will never go away as long as it has mass. But since this is just a force and not an energy, the never-ending nature of gravity cannot be used to extract infinite energy, or any energy at all for that matter. Think of gravity loosely like a rubber band. Stretch the rubber band and let go, and it snaps back into place. You can therefore store potential energy in a rubber band by stretching it, and this potential energy becomes kinetic energy when you let go. But an unstretched rubber band just sitting there won't move at all, and can't create any energy. The energy you see in the rubber band snapping comes from you stretching it, and not from the rubber band itself. Neglecting heat losses, the kinetic energy that comes out of the rubber band, how much it snaps, is exactly equal to the potential energy that you put into it using your muscles, how much you stretch it. Lifting an object against gravity is just like stretching the rubber band. Confusing energy and forces leads to nonsensical ideas, such as free energy, perpetual motion machines. Such machines always fail precisely because forces are not energy, and you can't extract one single bit of energy from a force itself. For instance, a free energy machine could consist of a ball that rolls down a hill and hits a paddle, which turns a wheel. The problem with this machine is that the ball has to be returned to the top of the hill for the process to continue, and the amount of energy you have to put into your machine to put the ball back at the top of the hill equals the energy you get out of your machine from the spinning wheel. Actually, the amount of energy you get out of your machines is always less than the energy you put into it, because some of the inputted energy is wasted to heat energy through friction. Free energy proponents devise ever cleverer ways to get the ball back to the top of the hill, or the magnet separated again, or the rubber band stretched again, etc., hoping that just one more extra gear or wheel will somehow magically create energy out of nothing. But they can never get around the fact that forces are not energy, and you can never get more energy out of a system than you put in. What about hydroelectric plants that extract energy from the falling water in rivers? Don't they extract energy from gravity for free? No. The water in the river is no different from the ball that you have to haul up the hill. The water got its energy not from gravity, but from some external agent that placed it high up in the mountains against gravity, so it could fall down the riverbed. The external agent in this case is sunlight. Sunlight warms the ocean, causing the water to evaporate and float into the sky. The energy contained in the photons of sunlight is converted to the potential energy of the water molecules that are lifted high in the sky. These water molecules then rain down to the ground, form rivers, and flow back down to the ocean, converting their potential energy to kinetic energy, heat, and, in a hydroelectric plant, electricity. Ultimately, therefore, hydroelectric plants extract solar energy from water. On Earth, gravity gives weight to physical objects, and the Moon's gravity is responsible for sublunar tides in the oceans. The corresponding antipodal tide is caused by the inertia of the Earth and Moon orbiting one another. Gravity also has many important biological functions, helping to guide the growth of plants through the process of gravitropism and influencing the circulation of fluids in multicellular organisms. The gravitational attraction between the original gaseous matter in the universe caused it to coalesce and form stars, which eventually condensed into galaxies. Thus, gravity is responsible for many of the large-scale structures in the universe. Gravity has an infinite range, although its effects become weaker as objects get farther away. Gravity is most accurately described by the general theory of relativity, proposed by Albert Einstein in 1915. This theory describes gravity not as a force, but as the curvature of space-time, caused by the uneven distribution of mass and causing masses to move along geodesic lines. The most extreme example of this curvature of space-time is a black hole, from which nothing, not even light, can escape once past the black hole's event horizon. However, for most applications, gravity is well approximated by Newton's law of universal gravitation. This law describes gravity as a force causing any two bodies to be attracted toward each other, with magnitude proportional to the product of their masses and inversely proportional to the square of the distance between them. Current models of particle physics imply that the earliest instance of gravity in the universe, possibly in the form of quantum gravity, supergravity, or a gravitational singularity, along with ordinary space and time, developed during the Planck epoch, up to 1043 seconds after the birth of the universe. This possibly emerged from a primeval state, such as a false vacuum, quantum vacuum, or virtual particle, in a currently unknown manner. Scientists are currently working to develop a theory of gravity consistent with quantum mechanics, known as quantum gravity theory. As we conclude our exploration of gravity's role in the universe and everyday life, it's important to consider the future possibilities and challenges that lie ahead. While gravity is a fundamental force that shapes our universe and influences our daily lives, harnessing it as an infinite energy source remains a challenge. The potential is immense. Imagine a world where the power of gravity could be converted into a sustainable energy source, reducing our reliance on fossil fuels and providing clean, limitless energy. However, the technology and understanding required to achieve this are still in their infancy. Scientists are working tirelessly, exploring theories of quantum gravity and striving to develop new technologies that could one day make this dream a reality.